Hello and welcome back to the third video on NLP Zero to Hero. In the last videos, we covered how to perform text pre-processing on our data, and then we looked at different techniques for vectorizing like bag of words, TF-IDF, and word-to-vec. We built our custom word-to-vec model, and then we also used pre-trained word-to-vec model, which was Google News 300 dimension model that we used. And the best accuracy that we got was basically using TF-IDF and SVM, which was 90%. Bag of words also performed really well, and the accuracy was 88%. But when we used the pre-trained word-to-vec model, our accuracy was 86%. Now we are going to use recurrent neural networks, and we'll be starting with the most basic recurrent neural network, also called a simple neural network or Vanilla RNN. So I have already built this model, and again, these are the models that I'm building from scratch here. So, and neural networks require a lot of training, a lot of hyperparameter optimization to get the best results. So here, there is a lot of scope of improving this particular model or any models we made in the past. But this is just for the demonstration purpose, for learning purpose, So there are basically two models that I made related to Vanilla RNN. One is this one, and the other one is this one. So when in the first model, what I did is I actually used the column of pre-processed text. So as you saw previously, we pre-processed our text, and that is what we used for techniques, NLP techniques like bag of words, TF-IDF, and word-to-vec. But in recurrent neural networks, I have seen that you don't really have to pre-process your text. You can just give it the raw format of text, and it can learn in a better way, because there are a lot of things which might get missed if you pre-process your text, if you remove stop words or something or the other. So recurrent neural networks perform better if you are just passing in the raw text. This is something I observed experimentally as well, and this is something I have read as well. So for that reason, what I did is I built two models for Vanilla RNN model, and all the models that I'm building. In one of the models I use pre-processed text, and the other model I use the raw text. And here I did not perform I have not used early stopping or anything else, but it's just a simple model where I'm taking a batch size of 128. I'm adding a dense layer. The activation function is softmax, optimizer is Adam. So all these hyperparameters can be played with. You can try different hyperparameters, and definitely the performance of this model can be improved. So this is what I built. This was a very basic model, and I ran it for 25 epochs, and finally the accuracy that I got was 82.34%. Then in the other model, the Vanilla RNN model that I built, what it did is I passed the raw text instead of pre-processed text, and I just applied early stopping in that, and the patience I took was 10, and that's it. And then I ran this model, and I was able to improve the model, Vanilla RNN model, from 82% to almost 85.64%. So that was a good improvement of around 3%. And I'm pretty sure we can improve this model as well. But this is what I got, and it stopped after 12 epochs. Then so there's a huge problem with Vanilla RNN, and that is of the gradient it is of vanishing gradient. So basically what happens is, when you have very long text and when the backward propagation happens, during the backward propagation, if you have a long text, you take the derivative loss, and then these values keep on decreasing, and finally they just vanishes. So it is not able to remember a lot of things, and that's why LSTM model came into play, which uses something called forget gate. What it does is it keeps all the important information and forgets the information which is not required. So that is how this one is better than the last model. And then I used LSTM here, and this was again using the preprocessed text, the first model, and the accuracy that I got was 85.43%, which was pretty decent. And in the second model, what I did is I used the raw text data, instead of using a preprocessed text, and I also applied early stopping here, and there was no other change I made to the model. And yeah, I did add dropout layer to make sure that overfitting is not happening here. And just after 6 epochs, I was able to get an accuracy of 86.4. So there was not a huge improvement, but there was an improvement of around 1% here. Then I used GRU model. Now GRU model is very similar to LSTM model. The only thing is that it is computationally less expensive compared to LSTM model. And I will leave some notes in the description below to read more about the theory of this particular model. And in the first model of GRU, again I used the preprocessed text data, and the accuracy that I got with this, I did not apply early stopping here, and the accuracy I got was 86%. But when I tried to optimize this a little, I mean just by adding a dropout layer and then applying early stopping, and instead of passing the preprocessed text, passing the raw text, I was able to get an accuracy of 85.6%. So here in this case, my accuracy decreased by almost 0.5%. So this is the only model where this happened, where I did not use raw text, where I used raw text instead of preprocessed text, and my accuracy dropped by a bit. So I mean, it's not much, so we can't really say that it was because of the raw text or it was because of preprocessed text, but yeah, this is what happened with the GRU model. Then in the end, I used bidirectional LSTM. So this is just like LSTM, but it's like, it captures from both the side, from starting timestamp to the end timestamp, and from end to the beginning. So basically it captures everything from both sides. And it is computationally much more expensive compared to, LSTM or GRU models. And I built the model. The first model was using the preprocessed text, and the accuracy that I got from that was 85.18%. And then I added the dropout layer, I added early stopping, and the third thing I did was basically use the raw text instead of preprocessed text, and that was the only change I made. And the accuracy that I got was 86.73%. So yeah, there was a good improvement of over 1.5%, which is good. And this is what is this? This is also bidirectional LSTM. So yeah, I'm getting almost similar accuracy. So these were the accuracies I got, and you can see that none of these models actually performed better than my TF-IDF with SVM or bag of words with SVM model, and that is a little surprising. So then I used transformer model. I didn't build transformer model from scratch, rather I used pre-trained transformer models. So there are models like GPT, models like BERT, and I used BERT based model called DistilBERT and Roberta. So in the next video, I'll be discussing about those models, what were the accuracy, and was transformers based model able to perform better than the best model we have till now, which was TF-IDF and bag of words with our SVM model. So that will be all for this video. I'll see you in the next video. Till then, happy learning.